Hi folks, this is Conundrum again. This time we're going to talk about the horizon. This is how we learned at school that light travels in straight lines and that the horizon is the maximum distance we're able to see, right? Wrong. All we learned is fine, except that nothing is stopping us from seeing objects that are thousands of kilometers away from the horizon limit. For example, the sun, the moon, ships and buildings and aeroplanes beyond the horizon. So what is the angle of elevation of the horizon? If we take a camera and we level it, it means that we're aligning it with the water level at our position. If the earth is curving, it means that the water and the ground is curving away from us. That means that in order for us to point the camera at the horizon, we have to also point our camera down, like this, thus moving it away from water level in a negative inclination. So the horizon is never level, it is always negative in the global sphere model. The same is true for the flat Earth. Since the Earth is flat, it means that at the cutoff point, called the horizon, we have to point our camera down towards the ground, thus breaking away from the water level into a negative inclination. In the concave Earth model, although theoretically possible to have a positive inclination angle to the horizon, Navy data indicates that it is in reality negative. So tests should be run to verify the Navy data as correct. So for the purposes of this video and until new data arises to the contrary, I'm going to assume that all models, including the concave Earth model, show negative inclination angles to the horizon. Watching one of the flat Earth videos, I came across mention of lighthouses and how they prove that the Earth is flat. Let's watch one of these clips and try and catch the insinuations that they're trying to implant in our brains and the outright lies that they claim for truth. So I looked into lighthouses and how ships navigate by lighthouses at night. And I came across another video from the US Navy that shows how navigators navigate ships at night using lighthouses. In the video, it showed how the light from a lighthouse appears out of nowhere in the middle of the night, just on the edge of the horizon. And this is also how we learned at school that the Earth's bulge is what causes the obstruction that we call horizon. At each position where we're at, the water level is at 0 degrees. This is how we measure things. But the horizon is in the negative degrees, not 0. The horizon cannot be 0 because you have to look down towards the Earth in order to see it. This is true always for the global sphere theory, the flat Earth theory, and the concave theory, because the observer has to look down. So, looking towards the horizon, you always have a negative elevation of the horizon. But the Navy noticed that light from lighthouses behind the horizon reaches them much lower on the ship than theory anticipated. They explained this phenomenon as being caused by atmospheric refraction, the bending of light. How do they envision it? Like this. Based on the Bowditch Naval Manual, light travels in an arc with a function relating its height above ground to the square of the curved distance away from the source. So, depending on the distance you have from the source, that will determine how high you have to be in order to see the light. So they determine that light reaches much further than without refraction. So instead of being here to see the light, you can be down here and still see the light from the lighthouse. Also, they noticed that light reaches much lower than without refraction. Instead of having to be up here in order to see the light, if it came in straight, you can be down here and still see the light. So the Bowditch Naval Manual shows that light bends both ways, behind the horizon and in front of the horizon. It's a two-way bending of light with the horizon in the middle. That's where the horizon, that is where if you had a theodolite and you looked at the light coming from the lighthouse, it would be at 0 inclination. Here, the light is at negative elevation. If you are standing here, on the other hand, the light would be at a positive elevation. You have to turn your head up in order to see it. So for all intents and purposes, as they say, the Navy does not really care much as to how exactly light bends. They are more into navigation, destroying targets, controlling their line of sight. So they are more interested in easy, practical and quick ways of doing that. This is also why they consider the horizon a 15 feet elevated place, because they know that below 15 feet everything is strange at the horizon. So refraction, the global Earth theory claims, results in much smaller declination angles to the horizon. In theory, the light, if it traveled in straight lines, should reach us up here with such a large declination angle to the horizon. Whereas now, light reaching us down here, this results in a much smaller declination angle. This diagram is to scale. This is the true light path with refraction in the global sphere model. The green light paths are to scale and are plotted from the Bowditch naval manual light function. This is an exact representation of how the Navy considers things. So even though the Navy publishes information like this in their video, there are no straight lines in distances. The distances are in nautical miles on the surface of the Earth, and the light path is also in a curved arc around the Earth, just like this. This is a correct representation of what the Navy considers as an approximation of reality. So remember, the Navy indirectly admits that light is bending. The Navy horizon is 15 feet above sea level for a reason. And when two horizons meet, the horizon of the ship with the horizon of the lighthouse, you can easily see much further than you thought, as long as light is intense enough to reach you. Lighthouses. Each lighthouse has a different rating and intensity. This is an example. This lighthouse has a range of 30 nautical miles. The intensity is measured in candela or lumens. This is also a two-scale diagram on the surface of the Earth. This is a cross-section of the Earth. And we're gonna reenact the example given in the Navy video called Navigation by Lighthouses, Night Piloting 1943 US Navy. So we have Cape Charles Light, a focal height of 180 feet, distance 15.4 nautical miles to the horizon. I've marked here the theoretical horizon. That's 26.4 kilometers. But the naval manuals claim 15.4 nautical miles horizon, which is marked here with the orange arrow. We have an 8.5 nautical miles distance to the first ship, and we have another 2.4 nautical miles distance to the second ship. The light hits aloft the second ship at a height of 90 feet, and later on, as it travels towards, or sideways, not towards, but anyway, it travels in a sideways direction like this until the light of the lighthouse hits the bridge at the 23.9 mile mark. So this is a direct representation to scale. If we go to the lighthouse first, you see from the lighthouse we have a few straight lines coming out, and these straight lines are directed towards the ship here and the ship here. There's a red, a green and an orange line. As we can see here, both the green and the orange lines dip below the surface of the Earth. So a straight light will not reach the ships. It will actually impact the surface of the Earth and not reach the ships. And we see these two straight lines come behind the horizon and re-emerge here. The green re-emerges here and the orange re-emerges here, which is impossible. Straight light will never reach these two ships. So what I've done is I've drawn an extra red line, a straight line coming from the lighthouse to the horizon to point B here. This is the only line that is able to bypass the curvature of the Earth and hit the top of ship B. But this is not how it happened in the video. In the video, at point B, which is 23.9 miles away from the lighthouse, at this point the light was able to hit the bridge. This is not what happens here. In our diagram we can see clearly that no light is going to hit the bridge. The only light that's going to pass is going to be over the ship. So let's go to point C. Point C is 26.3 miles away. Here we see that all light rays are impossible. The orange light is seen, but of course it has to pass through the Earth to reach here. It's impossible. The red light is an impossible line also, because it will never hit aloft. So at point C we see that there's no light coming to this ship. So the example is impossible with straight light. So straight light is only for school kids. In order for you to learn trigonometry, the convex globe Earth model points to atmospheric refraction as the reason for the failure of this example of straight light. It is futile trying to make scale diagrams with straight light on a global sphere model. So for all intents and purposes, for example navigation, targeting, etc., the Navy is happy with their approximations in their tables. Straight light is only for school kids. It doesn't work on a sphere. So we have the same situation here, but on a flat Earth. We have the lighthouse, the horizon, and the two ships. I began by drawing a line coming from the horizon. It's this blue line coming to the ship at point B and hitting it at the bridge. And I extended this line and I forced it to hit aloft. So in order to do that, I had to bend the light ray upwards by 0.07 degrees. So a straight line from the horizon to the bridge at B and then aloft at C is not possible. The light has to bend upwards in order to do that. No straight line is going to hit aloft from the horizon to the bridge to point C. It's not possible. This guideline is a straight line. It's a dotted blue line. If we follow it to point C, it will hit aloft. However, it's not passing from the bridge, it's passing a bit further up. So there's no straight line, that will hit both places as noted in the video. However, let us help out the flat Earth theory by assuming that when the lookout went aloft at point C, the light from the lighthouse was already visible, in order to be flexible. So for this purpose, I exaggerated the objects, but the relative dimensions and the distances are exactly the same. This will help out instead of zooming in and zooming out all the time. So in this example, I drew a straight line from the horizon, straight through the bridge, and I let the line extend to wherever point that point C is gonna hit. So when the lookout went aloft, the light was already visible. It wasn't just starting to be visible, it was already there. In the video, the ship was actually moving sideways and not straight towards the lighthouse. But let's assume that the ship is traveling towards the lighthouse. When the ship reaches the horizon mark, the light from the lighthouse should now be visible above 15 feet, because the Navy considers 15 feet the elevation at the horizon. So the whole lighthouse will not become visible until much later. As the Bowditch Naval Manual specifies, when an observer is at the horizon at a 15 feet elevation, that's where he can see the lighthouse at the 15.4 nautical mile distance and at 180 feet height. Because if he is any further away from the horizon, he will not be able to see the light anymore. He will have to increase his elevation in order to see the light again. At 180 feet, the horizon should be at 15.4 nautical miles away. So the ship should be able to see the lighthouse anywhere from 15 feet up to any height. So from here onwards towards the lighthouse, the ship should be able to see something like this. If you use binoculars, you should be able to see something like that. The light from the lighthouse slowly emerging up above the horizon. From the lighthouse, you will be able to see a ship also emerging up above the horizon. Back here, the view from the ship will be either a whole light or a loom or no light at all, depending on the height of the observer. If you're on the bridge, you should be able to see a light. If you're below the bridge, you will see no light. If you're somewhere further back, you may see a loom, something like that. It's like a dispersion of light, because you can't see the actual light, you see its reflection when it's dispersing up into the atmosphere. And from the lighthouse, depending on how far away the ship is, we should be able to see parts of the ship rising up behind the horizon, because that's the description that we get from the Navy. The Navy says below the bridge there is no light, above the bridge there is light. This is what observation tells us from the Navy. At some point you see the light. A few minutes before it wasn't there. Now if the ship progresses and comes closer to the lighthouse, say at 8.5 nautical miles, what's the view from the ship going to be like? It's going to be something like this. You should be able to see the whole lighthouse and its light coming up from an elevated position, and you can easily measure an elevation angle to that light. You can take your sextant and measure the angle, which should be positive. From the lighthouse, you can clearly see a ship approaching now. And still, if you get closer, you can see that the elevation angle increases. And the same with the view from the lighthouse. You can see the ship increasing in size. Now, what do you think? If we put an observer at the lighthouse with a big telescope, do you think he's going to be able to see the ship that is missing? Do you think if we use a telescope we can remove the obstruction and see the ship, the whole ship, the parts of the ship that are missing? And what do you think if we equip an observer on the ship with a big telescope? Do you think he's going to be able to see anything? Do you think he's going to be able to see the lighthouse? If they are above the light line, the dotted yellow line, of course they will be able to see something. We have observers there that testify to seeing the light, also aloft at point C. But if we are under this line, if we are, for example, on the bridge at point C, do you think we will be able to see the lighthouse? Telescopes placed below the yellow dotted line will never see the light from the lighthouse. For example, point B. Please do not think that the light from the lighthouse is weak and this is why we cannot see below the yellow line. Remember that the light is strong enough to reach 2.4 kilometers further back to point C. So it is not a weakness of light, but rather an angle of light, pushing it upwards, further up, the further away we get. So telescopes do not help us here. It's height that will help us here. We need elevation in order to see the light from the lighthouse. However, if we place a telescope in the right place to be able to gather light from the section above, then we will be fooled into thinking that the light is visible in the dark section. We must be careful not to make this mistake. The whole lens of the telescope must be below the yellow line for this experiment to be honest. So something is happening here at the event horizon. There's an event happening. Something is forcing the water between the ships and the lighthouse. Either the Earth is bulging upwards into the light rays, or the light rays are bending downwards towards the water. It's one or the other. There is no other explanation for what is going on here. So we have the law of perspective on the left side from the horizon towards the light source, where elevation angles of the light source seem to increase as we get closer to the light source, and we have the law of something else going on the right side of the horizon. So if we draw straight lines indicating the straight light paths from the light source to each part of the ship, to the bridge, to the bridge, to the bridge, and aloft, we see that the light rays, all of them, have positive elevation angles. They're all above sea level, as we see here. So we have the bridge and we have the observer aloft. The distances from the light source and the elevations of each point. The angles, as calculated, are as follows: 0.049, 0.032. Even though they're very close to level, they're clearly positive and above the water level 0. So the angle of light elevation for each point is positive, and it's bigger than the angle of horizon elevation, which should be negative. If the captain at the bridge, for example, wanted to look at the horizon, he will look downwards. If he wanted to look at the lighthouse, he will look upwards. Even at a small angle, it's still measurable. So let's imagine we have 3 ships. One sitting at H and the other 2 at B and C. You can clearly see that the red light rays that reach points B and C pass directly above the ship at H. So what would it look like from the bridge at B if we were to look straight out the window? It would look something like this. We would see a ship standing at the horizon and a light from a light source passing above the ship at the horizon. But this is not what we see, what we observe. In the video it clearly states that the captain at the bridge just about managed to see the light at the edge of the horizon, not above. The same with the observer aloft. So something is happening here at the event horizon that's pushing the light rays down to the base of the ship at H.
Also from this table, he finds the distance of visibility for 55 feet, the height of eye of the Savannah's bridge, to be 8.5 miles.
So remember, the captain at the bridge of ship B can just about see 15.74 kilometers or 8.5 nautical miles. So the ship at H will be just exiting his line of sight it will be just at the limit of exiting his visibility range. So it will be just sitting on the horizon. So how come the light rays from the lighthouse are passing above it? They should be passing below it, below its base. It's impossible. Although strong enough to reach aloft point C, why can't the light reach the decks of B and C if it's coming from above? If it's coming from above, it should be able to illuminate the whole ship, both B and C. So isn't light obeying its law of straight lines? I thought light was traveling in straight lines. Why isn't straight light obeying basic light rules, like illuminating the whole ship? Why are these ships half bathed in light and half bathed in darkness? What's causing this if light is traveling in straight lines on a flat Earth? I wonder, what is the angle of elevation at B and C? As we said, the angles of elevation are positive, and this doesn't make sense. This is illogical. This is not what we observe, what the Navy observes on a day-to-day basis. This is to scale. This is the horizon, the ship at the horizon, and we see that the two red lines are passing above the ship, and they're going to point B. One is going to point B, hitting the bridge, and the other one is going to point C, hitting aloft. And we see that in the scale diagram, both red lines that are hitting the proper places are passing above the ship. This is impossible. This is not what we observe. The observer aloft reported the light appearing on the horizon. The captain at the bridge at point B reported the light just about making its appearance on the horizon, not passing at 100, 110 feet above the horizon. This is not what they reported. So there's something else going on. Something is happening at the event horizon. Something is forcing the water to either be raised up and touching the light, or something is causing the light to bend down and touch the surface of the water. There's no two ways about this. We cannot escape this. So light is coming from above the horizon and actually from above the ship at H. So the question remains, although strong enough to reach aloft point C, why can't the light reach the decks of B and C? What law is ruling this side? We know this side is perspective, but what is going on behind the horizon? What's going on here? This is what we have to find out. Even though we don't have data as far as the elevation angle of the light as viewed from B and C, we can be sure that it appears right on the edge of the horizon, not up there, because, as the video stated, they had a persevering lookout.
Note that Hog Island Light was sighted by a persevering lookout using binoculars.
And as they stated, the captain at the bridge saw the light when it became visible, not after 10 minutes. So the light appeared on the horizon. There's no point having lookouts. There's no point having a bridge looking for a light in order to navigate at night and seeing it 10 minutes later. They saw it as soon as it appeared on the horizon. And if they both saw the same light, it means the lines of the light should line up, because they're seeing the same light rays just about reaching them. However, as we see from our diagram, these two red lines, they don't line up. They have a huge difference between them. They should be lining up with the yellow line, so that the lookout aloft with his binoculars and the captain at the bridge with his binoculars are seeing the same thing as soon as it becomes visible. I hope you're following me. if we have two ships instead of one, and we have one lookout there and one lookout at the bridge here, and they raise their heads up above the yellow line, they can see the same thing. The same light ray is hitting both of them. However, these lines, they're different. They can be seen here, here, there, there. The red lines are not a reflection of reality, of what has been observed. So the lookout aloft at C and the bridge at B do not line up, and they should. They should line up with the red light rays coming from the lighthouse. Furthermore, as I stated earlier, the ship at H is sitting right bang on the horizon of ship B. Therefore, the bottom of ship H also doesn't line up with the red light rays. The red light rays should be at its base. So we have a problem here. To reconcile the problem, something has to bend. It's either going to be the light that will bend, like this, for example, flat earth theory and curved light, or it will be the earth that will bend, for example, convex, as we all know it from school, or concave models, or light and the earth. Both the light and the earth have to bend. For example, concave model. There is no other option. So in conclusion, I have to say that flat earth theory cannot work with straight light. One thing is for sure, light bends in the flat earth theory. There is no other way. So the law here that governs the side behind the horizon is the law of bending. Is the law of bending of light, or the law of bending of the earth. Flat earth theory cannot work with straight light. And now that light bends, then the view from the ship is correct. We see the light on the edge of the horizon. And so the bottom of ship H will begin to disappear as it moves further away until it disappears completely from the view of ship B. It will slowly start to disappear as it moves further away. In the same way as if we start doing a reverse from ship B, if we start our engines in reverse, the light from the lighthouse will also start to disappear. It's simple. So the horizon is called an event horizon because an event is taking place there. And the event in the flat earth theory, if the earth is flat, the event that's happening here is light bending. That forces the light to bend down towards the earth. This could be because light is naturally designed that way, that it has a natural curvature. Now these points are crucial and must be understood. The sea underneath the horizon cannot be removed by zoom or telescope so that we can see what is hidden behind it. This goes both ways, from the lighthouse to the ships and from the ships to the lighthouse. This can only be achieved by gaining height. This should immediately tell you that if the earth is flat, then light is surely bending. This is clearly visible in this video promoting flat earth. This guy is zoomed in all the way towards the horizon and he can see some building. Can he see the base of the buildings? No. Let's watch that again. He's zooming in. Can you see the earth disappearing? Can you see the base of the buildings? Forget about them being slanted. Where's the base of the buildings? You just zoomed in all the way. Where is the base? It's gone. So what, the mouse took it? The mouse ate it? What are you promoting here? This is the horizon. We're zooming in. And where is the base of the buildings? It's clearly missing. I don't see it. I don't see the sea moving away, disappearing. And I don't see any more of the building becoming visible. No, this is not proof of flat Earth. This is proof of an event taking place at the horizon. And that's either the Earth being convex, bulging out, cutting the light rays, or the light is bending, or both. It could be that the Earth is concave and that light is also bending in that case. This is not proof of flat Earth. Actually, it could be a flat Earth and light bending. But it's not straight light. Straight light cannot do this. This is impossible with straight light. Forget about straight light on a flat Earth. And number two, in the flat and convex and concave Earth models, the angle of elevation of the horizon is always negative. Even if it's small, it's always negative. You have to turn your camera, your view angle, below the water level at your position. So it's always negative because you have to point your line of sight down in order to meet the water level. When you see something appearing anew on the edge of the horizon, and you know that the object is at a higher elevation than you, for example, the light from a lighthouse, which is 150 feet high, is taller than you. The 6th floor window of a tall building, you know, is taller than you. Then you should know that the angle of elevation to that object should normally be positive. Under normal circumstances, you would have to turn up in order to see that. But if that point appears at a negative elevation, that should immediately tell you that if the Earth is flat, then light is most certainly bending. Why? It means it appears at a lower elevation than you on a flat Earth. So when you're looking at this, when you're looking at this, I don't know, the 20th floor of a building, the 10th floor, the 6th floor, even the 1st floor of a building, you should be looking at it with a camera elevation in the positive. Did the person taking this video check the elevation angle of his camera? He can see the 1st, 2nd, 3rd floor windows of a building on the edge of the horizon, and the edge of the horizon, I'm telling you, its elevation is negative. He's pointing his camera down towards the Earth to see the 10th floor window of a building. What does that tell you? It tells me very, very easily that if I'm on a flat Earth, light is bending. There is no other way that you can get around this. If the Earth is flat. So this is the law of bending, guys, on a flat Earth. Yes, if the Earth is flat, there is an obstruction and it's called light bending. If it's another shape, then it's another event is taking place here, which is the curvature of the Earth or a combination of both. So let's now quickly go to Luxembourg to Antwerp. And let's see the Notre Dame spire. There you go. This is it. Flat Earth theory claims that a great example is the Notre Dame Antwerp spire. Is standing at 403 feet high from the foot of the tower, with Strasbourg measuring 468 feet above sea level. Yes, this is it, the Cathedral of Our Lady, Antwerp. It says here actually that its height is 404 feet high. It's standing in Luxembourg, not Strasbourg, standing in Antwerp. Strasbourg. There's two Strasbourgs, one in France, one in Germany. This is in Antwerp. And as you can see from Google Earth, the elevation here is 4 meters high above sea level. 4, 6, 4 to 6 meters high. Is next to a river, and it's very close to the sea. Yeah. So you see, even here their information is incorrect. It has nothing to do with Strasbourg. It's not 468 feet above sea level. It's only 4 meters above sea level. So anyway, I have a scale drawing of the Notre Dame Antwerp spire at 424 feet in total, with its elevation above sea level. And I've placed it at 44.58 kilometers away from the common horizon of the lighthouse at Cape Charles. So you see, all these points now are joined by a common horizon. The lighthouse with the ship, with the horizon of the lighthouse, the horizon of the Antwerp spire, the horizon of the ships. So you see, they have a common. Now they're at the correct distance and at the correct heights to have a common line of sight to the horizon. So the ship at point B, since they can see the light coming from the lighthouse, they can also at the same time see the top of the spire at Notre Dame. That's 44.58 kilometers plus 15.74 kilometers for a total of 60 kilometers. That's the maximum distance that the Navy says the top of the spire can become visible. So at another 61 kilometers away and at a height of 810 feet, we'll have again a common horizon. At this elevation, at 810 feet, we can see the Notre Dame spire. At this height and distance, we have the same horizon. Now the elevation here, the declination towards the horizon, would have to be a negative 0.23 degrees if light is straight, and if light is bending, it would have to be almost double that. This is according to Bowditch. If we continue further down, if we move 150 miles away from the Antwerp spire, from this position, yes, if we had a ship sitting there, at this height and distance, we have the same horizon. So if we have a ship at 150 miles away that can see the Antwerp spire, then that ship would have to be sitting on the peak of a mountain at 8,221 feet. As we've seen up to now, the ship moving just 4.4 kilometers from C to B is greatly affected in terms of the light from the lighthouse, in that it drops from 90 feet down to 55 feet. That's a drop of 35 feet. So moving away from point C, moving backwards, you can imagine that just moving a few kilometers backwards, if the spire is in view and you start moving backwards, you're going to stop seeing that. The light coming from it will lift up and you're going to have to go further up in order to see the spire. So how can somebody that has moved back 150 miles, it would have to be a flying ship. So this is impossible on any Earth, and you have three options. One, you're navigating a flying ship. Two, it's a mirage, which is possible. Mirages happen all the time. And three is just lies. Yeah, as we've seen from the beginning, the Notre Dame Antwerp spire has nothing to do with Strasbourg and is not 460 feet above sea level, but only 4 meters. Yes, and flat earth theory is full of these inconsistencies. I've seen them everywhere. So are you beginning to see a picture here? The flat earth theory and straight line is bull, and any model with straight light is bull. Straight light exists only for all intents and purposes in your average daily life, at short distances, in wild cuckoo land, and in children's textbooks. That's where it exists. Having said that, you can knock yourself out and do some FET tests to prove straight light if you like. You can take a theodolite and go measure the horizon declination angle from level down to the edge of the horizon from every height possible. Your equipment must be sensitive enough to measure angles to 2 or even better 3 decimal places. The horizon declination angle and its distance are key to the nature of our reality. Compare what you find with this formula. The above formula was derived from the Bowditch manual and assumes straight light paths. This is a myth I hear a lot, that the horizon is always level, and I say no, the horizon should drop with higher elevation. And if you want to do tests to prove straight light in the flat earth theory, you can use this diagram. It's a comparison of horizontal declinations of the two models, showing clearly the huge differences between them and how easy it is to determine which one is closer to reality. Both graphs were computed using straight light. This is why I believe this is wild cuckoo land. So these are distances versus angles of declination to the horizon. For objects making their appearance on the horizon with straight light, the flat earth theory's horizon will always be at a smaller declination from level compared to an almost double declination angle for the global sphere model. So you can go to any elevation above sea level and measure the horizon and see if it's closer to flat earth theory or closer to the global model of straight light. However, I do not believe that flat earth theory can work with straight light, as it must have become clear to you also in this video, where it was proven already with the ships and the lighthouse. This is wild cuckoo land for me. The flat earth theory with straight light is for school kids, is proven wrong by the Navy and by this video. The globe earth model with straight light for school kids, again, was proven wrong by the Navy. The Bowditch manual clearly shows light curvature. Now the concave earth theory requires bending light and is proven right by the rectilineator experiment. So let's step into reality for a minute. Let's look at reality according to the Navy navigators. The following light paths are to scale, and they're decoded from the Bowditch Naval Manual's function for light bending due to refraction at the horizon. Unfortunately, we humans are so small compared to our Earth that we have to be 3,000 kilometers away from the horizon and 500 kilometers up above the ground to notice 1 or 2 degrees of difference distinguishing one model of bending light from the other if light is really bending the way the Navy has calculated in the Bowditch manual. And this I find weird, that we cannot distinguish one model from the other based on horizon elevation angles if light is bending. Only the rectilinear experiment is the definitive proof for the shape of the Earth. So these diagrams are to scale. The first diagram is the flat Earth theory with bending light. The pink line is the bending light at different distances. The 2 points have a distance between them of 1/4 Earth circumference. So that's about 10,000 kilometers. This is the globe model with bending light. According to Bowditch, this is the curvature of light. The Earth is this line, this red line is the Earth's outer surface. And this is the concave, is the same Earth basically, but we're looking at it from the inside. It's the same mountain, let's say, it's a mountain. One mountain is pointing outwards for the globe model, and one mountain is pointing inwards for the concave model with bending light. The bending light for the concave is this line, this red line. So this is an accurate 2-scale depiction of how light bends in the different models. What I also find weird is the path of bending light in the concave Earth model. It falls neatly very close to the center of the Earth. And I wonder now if I can approximate the distance to the Sun in the concave model. So in closing, let's recap and clarify our thoughts a bit. There is only one truth. Everything else is a lie, even if, for all intents and purposes, it approximates reality and suits our daily lives just fine. The Navy functions on known and well-tried principles for hundreds of years. Do they know the whole truth? Are their tables the truth? I don't think so. Only the creator of this amazing clockwork can show us the truth. Is the Bowditch manual relied upon for safe navigation? You bet. Does it show light bending? You bet. Is light bending as per Bowditch all the time? Well, the global sphere model says that this happens only at the horizon and that all other light is straight. The Navy manual, however, suggests that all light bends all the time. Flat Earth theory says that light is straight, and this is why the flat Earth theory is a failure at the horizon. The concave Earth model says light bends. Well, I say light definitely bends at the horizon and all other times, and probably even more than Bowditch claims, thus explaining the Bedford level experiment. Bending light just makes everything around you appear flatter and stretches the sky like a canopy over you. If I had to place a bet right now, I would place it on the Bowditch data until even more accurate data emerges. Please note that the manual has been revised since 1943, with some notable differences in horizon distances. So as I said before, even the Navy cannot be taken as gospel. As far as light bending is concerned, we need more experiments, so check out bendy light. Does the global sphere model work with straight light? No. Does the flat Earth theory work with straight light? No. Does the concave Earth model work with straight light? Of course not. Do all models work with bending light? Yes. Actually, if we take Bowditch formula as our best approximation to reality, you wouldn't be able to tell the difference between them unless you went up hundreds of kilometers into space. Do I know what shape the Earth is? No. We all need a remake of the rectilinear experiment, which is actually taking place now. I think the Earth is probably concave, and I base my opinion on the old rectilinear experiment, the ether experiments that show the Earth is not spinning, and based on Tesla's comments on Einstein, plus the insanely adamant obstinance of atheists such as Haley to make up lies in order to avoid the obvious truth that the Earth is the center of the universe, as proven by the background microwave radiation satellites sent into space since the 1980s, and to avoid the unavoidable reality of our Creator God.